Okay, now that you've found out where to store your stuff, maybe I'll keep my video off. I'll talk about what the software, the FAR detector and ProtoDune uses. Of course, DUNE is a joint collaboration with a lot of different kinds of software. Near detector and the beam and people doing their own test stands have a lot of different software stacks, but the biggest ones that are shared by more collaborators than others are the FAR detector and the ProtoDunes, because they're the biggest detectors and they have the most data right now. So we use the ART framework in order to manage our software workflows. It's something that was forked off the CMS SW or CMS framework about 10 years ago, maybe a bit more than that, but the original paper is about 10 years old. And it's meant to be a simpler framework than the CMS one, but it really evolved in the last 10 years and has provided a lot of features. So in fact, it's you might find it has a bit of a learning curve, and that's because it's doing all these things. It defines the event loop, so it's does a lot of its I/O with root, and most people who use root in order to loop over events write their own event loops and say, why do you need a framework to loop over events? And the reason is because of all the other features, is that it needs to store metadata, it needs to manage the event data storage in memory. One issue when you've got a giant collaboration, DUNE has about 1,300 people on it, and we're all contributing software. Well, not all of us, but a lot of us are contributing software. You don't want some person in the collaboration scribbling over your data in memory just because they ran their bit of code after your code and decided that it wanted to overwrite the output of your module. So what ART does is it declares memory as const, which keeps people from overwriting it, which means that if you want to calibrate something and change a value, you actually have to make a new calibrated, changed version and not overwrite the original version. It defines the input file interface. So if you want to loop over many files, it has an easy interface for that. Schedules module execution. So many people are writing different bits of code and they want to execute them in a particular order or try different orders. And these orders can be configured by a text file called Fickle file. We'll talk about Fickle files. Now, one thing that root provides, which is great, is that it lets you store the contents of C++ objects, class objects in files, output files. And C++ does not let you do that. You have to write your own serializers, but root does this for you. But you have to provide dictionaries and everything for root to store things on files. So there's a way to define data products for storage, and we can talk about that. There are associations between data products, so you have tracks with hits on them, or hits are associated between views in the detector. The associations can be done that way. There's a configuration interface called Fickle. We'll talk about that. We store the job configuration in ART formatted root files. So if you get a root file from somebody and you have no idea how it was made or what's in it, you can dump the configuration and see how it was made. And various other things like random numbers and exception handling. So let's go ahead and get set up to try things out. So the mission setup had this DUNE pre-setup, and let's go ahead and try this. I've got a terminal on my laptop here, and I'm just going to log into a DUNE GPVM. And I assume that most people are afraid of 13, so I'll log into 13. Tutorials, and I put things in a tutorial directory, May 2022, because I've got several tutorials, and I'm going to source the DUNE setup. And then I should have a this alias, DUNE setup, which will source that. And what am I supposed to do here? I'm supposed to set up the DUNE software and cut and paste, because I often make mistakes. Set up FNL security. Incidentally, you can probably check to make sure that you've got a valid Kerberos ticket that has yet to expire. If you forget the date, you can type that to check against the expiration date. Okay, so that's the same stuff that you saw Tim execute in order to check the data. So I'm doing this on a Fermilab machine. If you're at CERN, then the input files I copied to my public AFS directory. CVMFS is available on the LX Plus machines, and the input files, which you need authentication for, I copied over to this public AFS area. So you already saw Steve do this command, AK plus, which produces a small printout, DUNE SW. So this lists all versions and of DUNE software, and it's not a sorted list, even though it may look sorted. Don't depend on it being sorted. The qualifiers, these say that not only do you have we release this every week. When the LARSoft versions come out, they come out once a week, and then we use the same version tag, and it looks like Jake put a little D00 on the end of that. So every week we get a new version, and the qualifiers, they're to describe how the version was built. And we typically build 4 versions, one with the GNU compiler E20 and one with Clang, which is C7. These are just labeled which compiler versions they are. Prof means compiled with optimization turned on. Historically, this meant that there was a profiler code that was built into the executables, but that's no longer true. It just means it's optimized. So in general, if you want to run the code, you should run the prof. Debug is essentially the same thing, but it's with optimizations turned off. So the debugger is sometimes a bit confusing to run if you've optimized the code, because the program counter jumps around and a lot of variables have been placed into registers or removed entirely if they're not needed. Debug will make your program a lot easier to understand when it's stepped through in the debugger, and you can examine all the memory. Okay, so the flavors in UPS, that's what this Linux thing is. We actually only support one flavor these days, and that's Scientific Linux 7. Older versions, you may find Mac versions and SL6. So that's the operating system, is the flavor. Some UPS products don't have flavors, they're null. So DUNE par data, UPS list AK plus DUNE par data. Essentially, it's a bunch of root files. And there's no code in it. It's not built with a compiler. It doesn't care about the operating system. So this has flavored null for all versions. So you already heard about the setup command. Type setup. If you say which setup, it's actually, you'll get, oh, that's the wrong one, because setup is declared as a bash function when you set up UPS, and this calls or executes the UPS program to set things up. One of my favorite commands is UPS active, which says which products you have set up. And this is that big stack that Steve referred to. And here's that dependency graph that Heidi mentioned. It's in the CDR. This is a new one for the version that we're running now, V094801D00. And here's the big stack. If you want to know where root is down at the bottom here. Everything depends on root. A lot of things depend on root. And then there's Géant. Géant's in here somewhere. And the DUNE specific stuff tends to be on top here, the LARSoft products, and then system things like root and Python, SQL and concurrency and boost are all down below. So those are the packages that get set up and you can explore. Art is one of the dependencies of LARSoft. It's the framework that interfaces to root and provides that functionality. There are also a bunch of Art command line tools, and these are listed on the Art wiki page, which you can click over here. And here are the Art command line tools, and we'll step through them one at a time here. So one of them is config dumper. So I mentioned that an art root file will have configuration information in it. So I can execute config. Is it dash or underscore? Underscore. And a lot of these commands, in fact, all of them have a help feature. So you just put in dash dash help, and it'll tell you how to invoke the command. So turns out that the default arguments for config dumper aren't usually what you want. You want to use the p argument to config dumper, because this prints all the process configurations. Otherwise, you get a subset. And one of the problems is you don't get art service configurations. You just get the modules. And we'll talk about services and modules. So I'm going to run this on a file. So this file is one of the xrootd URIs, and you get that from SAMWeb. Get file access URL, and then the schema is root, and we should have that command in the wiki. And certainly on the how to access data, it tells you how to get SAMWeb URIs. So here's one of the example files. We only have 2 example files for this entire tutorial for art LARSoft and modify module. This is a Monte Carlo file, so it's PDSP prod 4. The space charge data-driven means that it's a simulation of the space charge. So I can tell that this is a Monte Carlo file. So I'm going to dump the configuration of it. It'll take a little bit using xrootd, and then I'm going to pipe that to an output file because there's way too much of it. And that's what this says, please. Oh, I dumped it to a file called temp.txt, but it turns out that this is a Fickle file itself. And you can use it as a job configuration, except it's got a little bit of dreck on top. So if you really want to use this as a Fickle file to configure a job, you can remove that extra little, a few extra lines on top. So in this configuration file, I always have to search through it because it's so long. Let's see how many lines there are. It's got 11,641 lines in here, and these are configuration blocks. It's not an actual programming language. It's just a key value pair language, which says what the variable name is, what block it's in, and what values it gets. And some variables are arrays, and some are strings, and some are numbers. And you can read through an example configuration to get that. Okay. So there's actually a separate quiz, but maybe I'll go through just one of these. This is the easy one, is looking for a particular string. Now, not every generator is labeled as a generator in here, and I happen to know what some of these generators are called. So let's see, let's just do the GDML one. So I'm going to look for GDML in the configuration. So this means that this particular Monte Carlo file was generated for ProtoDune, and Dune has many, many detectors. We've got 2 ProtoDunes for ProtoDune 1, and then we've got another couple of ProtoDune 2s. It's horizontal drift and vertical drift are coming, but the ProtoDune SP was single phase and there was ProtoDune dual phase. We also have different kinds of FAR detectors and cold boxes. There's iceberg. So there are geometries for all of those things. And this is the version 7 of the ProtoDune geometry. So that's how to look at that. There's trigger path. Trigger path says simulate. And then I look for simulate. Yeah, simulate. And that says run opdigi CRT. Huh. I want the generator. Generator, random number generator. If I know that this one has argon. And there's argon 39 is one of the generators. There we are. So there's generator. So that's the answer to one of these questions, is which ones of these generators there are. And it turns out one of them is called generator, and these others, you can stack a whole bunch of generators in a row. In this case, we actually have several instances of the same generator, just configured differently. So we have a radiological generator that is configured to generate argon 39, another instance of it to do the argon 42, another instance to do krypton, another one to do radon, and a separate generator to do cosmics, which I believe is Corsica. Okay, I'll let you answer the other questions there by looking through the configuration. So another command line tool that is very useful is Fickle Dump. This config dumper was useful for figuring out how the configuration was set up for a particular file. If you don't have a file yet and you want our debugging configuration, or you just want to know how a configuration works, there's Fickle Dump. So in this case, we have this command, and Fickle Dump itself has a help feature. Maybe I should show you what's in this Fickle file in the first place and show you why you might want to need Fickle Dump. And I've got my own little script called LSFickle. And it'll find this Fickle file. It should be in DUNE SW. And there it is. It's in the DUNE SW Fickle directory. And they're in Fickle file path. Let's see. So this Fickle file is not very big, but you notice that it has some include statements in it. So these include statements include other Fickle files, and those include other Fickle files for an entire tree of inclusion. The Fickle file that is generated once all the includes are executed is called a Fickle document. And what Fickle Dump will do is it will follow all those includes and do all the substitutions. It'll take these locals and tables and whatnot and substitute the things that they are defined to be that are defined in these other includes and flesh it all out. So that's what Fickle Dump will do. And I should mention what this LSFickle does. It just looks at the search path, Fickle file path. That's one of the paths that Steve showed when he talked about UPS. So it's a colon separated search path for Fickle files. And you'll notice that the very first entry in it is the current working directory. So if you are working on some software and are playing with a workflow and you want to change a configuration, you don't have to install the Fickle files in any of these areas in CVMFS, especially because you don't have write access to them. You can just use the current working directory as some scratch for configuring your job. But make sure that you back it up and commit it to a repository and get it to install once you are happy with your job configuration. You want everyone to use it, not just yourself. So what that LSFickle does is it just looks in all these directories and found the ProtoDune refactor T4. So let's run Fickle Dump on it. What was that, hyphen or underscore? Fickle dash dump. So config dumper had an underscore and Fickle Dump has a hyphen. And it's got some help. And I can go ahead and let's see, dump that Fickle file. So what that will do is it will follow all the includes and do all the substitutions. And then this should be about 11,000 lines long. And that's got a little bit of dreck in the front too, but if you remove it, you can have a perfectly executable Fickle file that you can give to LARSoft. So that would be the configuration information that would go into a file that would be created by a job running with that configuration. Count events does what you think it should do, just counts the number of events in there. So that's the same Monte Carlo file that we had. And if I do count events, underscore events this time, help, it'll say what those, oh, HR. So it gives me 4 numbers, but I don't understand what those numbers are. I'm just going to follow the help for human readable output, and they'll hopefully label what all these are. So there's 1 run, 1 subrun, 10 events, and 0 results for that. A result is something like a luminosity sum that is not event data, but Art keeps track of things.
Most Monte Carlo files have only got 10 events in them.
Mm-hmm.
For fire detector, for photo doing that's the trend.
Yeah. So one thing about DUNE is that our events are absolutely gigantic, and they take a long time to process. So like half an hour to process, and they're a few hundred megabytes from ProtoDune, but a fire detector non-zero suppressed raw data set will be about 4 gigabytes for a single event. Of course, we compress and we zero suppress, so you might get 10 events in the file. Okay, another command line tool is product sizes dumper. Control A gets you to the beginning of the line, product sizes dumper. So what F0 does is it says dump all the products. Otherwise, product sizes dumper will only dump products that are big enough over some fraction. And this says dump the ones that even have 0 fraction. So that says that most of the data in this file is in the events T-tree. That's where root stores all the event data, but there are other things. There's metadata, there's configuration information. There are those results I just talked about, and those are all very small. So here are all the data products, and I mentioned that root and art lets us store data contents of C++ objects, and these are the standard data products, things like MC particles and MC truth. Things like tracks and hits are reconstructed objects. MC particles are simulated objects, so you find sim. The B means base, so these are base classes. And B is analysis base. So calorimetry is a property of tracks and hits, is the amount of charge that's been, or even energy that's been reconstructed with an analysis producer module. So there are associations that I mentioned up at the top that say the associations between space points in 3D and hits, which are really 2D objects. A hit is a pulse that's been found on a DAC channel. So we read out the liquid argon TPC with ADCs that are attached to each wire that are on the APAs. So a hit is a pulse that's found on the wire. And then you have to associate the hits in the 3 views in order to figure out where they are in 3-dimensional space. So that's done with Space Point Finder or Pandora, and then you'll find space points on this list, and then associations between hits and space points. Oops, are in there. So there are explanations for all of those data products. And I believe there even is a link to a nice talk from Tingjun and the 2019 ProtoDune analysis workshop at CERN, which describes a lot of the main data products that people use in analyses. Okay. And then there's another thing that you can do, and that is, let's see, you can open up one of these root files with root. And I'm not using VNC here, although I do have a session up. I can just open this up in root. My internet connection should be fast enough that I can just browse this file. It'll be a little bit on the pokey side. And there it is. Is that too small? There's a bit of latency. Hello. There it is. So the events T-tree is where all the event data is. That's what we found in product sizes dumper, is that the events T-tree is. And then you can actually click on individual leaves in some data products. This isn't the greatest because the data products themselves are sometimes very, very complicated structures inside, but some of them you can opt at waveforms, for instance, and we'll look at that one. And things like the object, and then they should have a channel number. There it was. This is slow. It can sometimes click on a leaf like channel number, and sometimes it even has a red exclamation point, but it'll still be able to. So this is a histogram of the hit channels and the opt-at waveforms. And you can use a T browser with a zero code in order to make distributions of various things in art root files. This doesn't work for everything, and you can experiment to your heart's content. Some things take a long time to decompress and may not even work, but this is a good way of getting at some things that if you just want to get an idea of what's in a file, then a T browser will tell you the contents. Do we want to save the quiz for later? What's the quiz? Did you take some of these items and make a quiz out of it?
You can work through some of those questions if you want.
Yeah, so this, things like, what's the name of the data product that takes the most space in the file? That's the output from product sizes dumper. And what did I do? Oh, product size dumper. Let's count events. Let's pipe that to another output file and look at it with my favorite text editor, Emacs. Oops, that's the X window version. This terminal. So the one that takes the most size is MC particles. It's right on the top of the list. So simulation-based MC particles. This is the art module label, and that made it large ant, and which some people pronounce large ant. And the name of the job that ran it was G4 stage 1. There's actually an empty string between these two underscores. That's the instance name. So if you've got a module that makes two collections of MC particles, you can distinguish them with an instance name. Not every part, in fact, most projects don't have instance names, but here's one that does. It sets the instance name to be PVS. So this is the module name, the module instance name itself, and the instance of the data collection within the module that it made. What's the module label for this data product? That's what I just said, it's large ant. And we can look through the configuration to see how large ant is defined. How many different modules produced SimB MC Truth data products? So let's look for SimB MC Truth. And that's an association, so we don't have to worry about that. We just want to know what's producing SimB MC Truth. So here's one, there's Argon 39. So we've got some true Argon 39 in here. We've got Cosmic Generator, Krypton. The generator is actually the beam generator, Radon, and Argon 42. And we saw those in the trigger path. Incidentally, Art will stick an S on the end of the data product name to make the T-tree branch name. So there'll be, and this S doesn't always make sense lexically, especially if things like axis are plural of axis. Okay, and the others are kind of similar. How many modules produce hits? So I just look for Rico B. And that's an association. I want to know which ones actually produce hits. Hit PDUNE and Gauss hit made hits. And that's actually an interesting distinction here, because I mentioned that hits are pulses that are found on wires. So that's what Gauss hit does, is it fits little Gaussian shapes to the pulses on the wires. Whereas hit PDUNE is a disambiguation step. Because the wires wrap around the APAs in DUNE, we need to be able to tell which wire segment a hit belongs to, and that needs to associate hits in the several views. So hit PDUNE is one of the disambiguation steps that produces another collection of hits. So the hits themselves are ambiguous until you run a disambiguator, but then we keep the ambiguous hits around because we can't overwrite memory in ART. We have to make a new collection of disambiguated processed hits. Okay, and I talked about looking at the ART root file with the T browser. This actually works much better in VNC, but I was doing it with an X server on my laptop. Okay, Summerford has already been underway to use HDF5 formatted files. That has been successful because the DAC people have been producing HDF5 formatted files, and we have a special input source method that reads HDF5 files very nicely. And we can even stream them with xrootd. That was something that was just found out last week. Okay, so the ART executable, there actually are several. The one that we use is called LAR, and that's the main program. LAR-help, because all ART executables have a help feature. These are all the command line options. So the features that I described at the beginning, that you can configure an ART job with a text file configuration, that's what -c is. Every time you invoke LAR, you should have a -c to give it a Fickle file to configure it. What LAR does is LAR is really a very short program, which LAR, and then I can ls-l, which is alias to LL in my environment. It's a really short file. It's only 149 kilobytes long. So that's not much of a program. So what LAR does is it reads the Fickle file with the -c, it parses these arguments, and then it uses the Fickle configuration to tell it what to do next. And a lot of the code that we provide are plugins. So things like reconstruction modules and input sources, analyzer modules, and all these things are plugin code that LAR will load up dynamically at runtime based on what's in the Fickle file. And you can tell it to process only some events and skip a few if you want, and then change the output file. So normally normally we process just one file at a time, and then you can put the input file on the command line for LAR without any of these flags, and they'll think that it's the input file. If you want to input a whole bunch of files, you can string them one after another. So you have ART root file 1, ART root file 2, or you can give it a list of files in a text file. So the -s is for the source file, or you can omit the -s and just say that LAR reads in its input file. Or you could give it a capital S, which is a file containing a list of files. So if you want to process 100 files and you don't want to put them all in the command line, you can put those in a text file that contains a list of files. So let's talk more about that job configuration with Fickle. So here's a link to the documentation for Fickle configuration, but I'll just talk about the things that you may run into regularly when you're doing your work. So one of the things to keep in mind, aside from the fact that will include other Fickle files, is that the parameters can be defined more than once in a Fickle file. So if you've got two declarations of the same identifier in a C++ program, the compiler will complain, but Fickle will not. In fact, Fickle rather likes it because this provides some flexibility in job configuration. So what happens if you've got two declarations of the same variables with different values, the last one wins. So if you have a job configuration that does almost what you want, you include it, and then at the bottom of this is a Fickle file itself, which contains 2 lines. One is an include statement for the Fickle file that does almost what you want. And then you poke this single parameter, which is a very common workflow. I want to study the lifetime or the drift velocity. Then I poke a new value into a single variable. And then this is a Fickle file that contains everything that you want, plus this one new value. And you'll find this idiom over and over again in DUNE Fickle configurations that say we want to generate Monte Carlo with a different detector configuration. Then we include a standard one, say for the FAR detector, and then we'll change the geometry to proto-DUNE or something like that. Okay, so looking for configuration blocks was in Fickle Dump. Jump to the Fickle. So if you want to know what block something's in, so suppose the readout window was one of the questions. Readout window size. So if I want to change the readout window size, and this is another little bit of history for how LARSoft evolved over time, is that 2 different people decided that they needed a Fickle parameter to say how many ticks we're reading out the time projection chamber for. So each ADC gets read out 6,000 times to make 1 trigger record in this Monte Carlo. But then 2 developers decided to put this Fickle parameter in, and they gave it different names. So some bits of code read one of these parameters and other bits of code read the other parameters. So if you ever change the readout window size, you have to change both of these variables. And we never made one of them go away because we were too lazy. So if we want to change that readout window size, I would say let's, what was the Fickle file that I had originally? Fickle Dump. It was proto-DUNE refactored G4 stage 2 .fickle. My G4 stage 2. And then I will include the Fickle file that does almost what I want. Oops. 2, and here we go. And if I want to change the readout window, I have to figure out what block this is in. This is in the detector properties service. Services, detector. Readout. And then readout window size. With a capital O. That's case sensitive. 2000. And then I can change, I need to change the other one. Okay, so that's how you would make a Jan4 Fickle version that changes the readout window size. Turns out that the readout window size is a property of the detector simulation, not the Jan4 step. So this is actually a little useless. This is a lot of the Fickle configurations over-configure things. So the service, which sets the readout window length, is actually not queried by the Jan4 step. What the Jan4 does is it simulates the physics interactions of the particles in the liquid argon. And if they go through the steel of the APAs, it does that too in the cryostat. The detector simulation part, however, simulates the ADC readout. So I would change this in the detector simulation Fickle file. But just as a general explanation of how to modify a Fickle configuration is this is what you do. You start with something that's already there, and then you add your changes to it. And then this thing does the same thing as Fickle Dump. You can run lar with the BugConfig, and it will produce a file that consists of all those changes. In fact, let's go ahead and do that. Lar debug config. .text. and then and then I need the -C to say that this is a configuration. And oh, it was supposed to change that to 2000. Oh, you know what I did? I misspelled that. Try that again. There it is. So I changed that to 2000 and everything else remained the same. Okay. Very good. And then there's an exercise to change the drift field instead of the readout window size. So let's talk about software a bit. How much time do I have? Do I have until noon or so?
That's correct.
Okay. So Fickle configurations are the easiest things to change. So if people have already written the software and all you're doing is running it with different configurations to do a study, that's a typical workflow, and that's probably what you should spend a lot of your time doing if you're running an analysis. But sometimes you have to write your own software. So the ART plugins come in various flavors. There are producers. They make data products that are put into ART's event. ART uses the word event to mean the data that is the smallest amount of data that ART can process. That's what the phrase in the ART workbook. So this comes from collider terminology where an event corresponds to a triggered readout of the detector. Because detectors, even the colliders, have a lot of pileup and events contain many interactions on them, people use the word interaction to talk about physics and events to talk about data. So ART uses the word event for the data, and they uses the word event to talk about the memory inside that stores the data from the trigger record. On DUNE, however, we decided that the word event is so ambiguous and overloaded, we want to avoid it entirely. So we're going to call it trigger record, but ART inside of it calls it the event. So when a producer module produces data, it puts it into ART's event memory, and you'll hear people just say, well, we put it in the event. So with the put method. So because ART stores its data in root T-trees, each entry in a T-tree corresponds to a trigger record. A producer module has to produce something for each trigger record that is processed, or each event that goes through its schedule, because if the different branches in the T-tree have different numbers of events in them, they get out of sync. And you'll get an error message from ART if a producer doesn't produce something that it promises to produce. So a producer module will have a produces method call in its constructor, which essentially says what the producer promises to produce on every event. So if an event is missing something, say there are no hits in the event, you can't expect the track finder to produce any tracks. So what do you do then? Because the producer module promised to produce tracks, and it couldn't because there was nothing to produce them with. So what you do is you create an empty collection of tracks and push that into the event memory. Other features of producer modules is that the source code, the build system, the way the ART build system works is that it understands that modules have to have source file names with _module.cc, where module name does not have any underscores in it. And the reason for all these little rules is because the Fickle configuration for modules, in fact, maybe we should go look at these modules, module type. Root output's one of the ones provided. Ion and synth, that's a good one. So module type is the name of a shared object library that gets loaded dynamically when at runtime. So when you run lar-c and then with this configuration, it sees a block for a producer module called ion and synth. That's the module label is IN and SINT, and then the module type is also called IN and SINT. So the reason there are different names for module label and module type is because you could have several instances of the same module. In fact, maybe radio. Is this one with 39 argon? No, I think I want to. That's 139 argon. Radio. So here's one where the module label is different from the module type. RadioGen is a shared object library for generating radiologicals. And this one has a module label of argon 39 because the configuration for it says to generate just the 39 argon. We can look up radio. And there's the radiological generator module. It's in LARSim. And when you tell ART to load up a radiological generator, it looks through the things in LD or set plugin path and finds the shared objects with this name in it. And because of all these other underscores, which say what repository and product they come from, and the fact that it's module means that there can't be underscores in the name of the module itself. So RadioGen is the name of the simple radiological generator. And that's a producer module. Makes MC truths for radiologicals, which are then simulated by Xiang. Analyzer modules do not produce anything. They just read data products out of the ART event, and then they produce, say, histograms or T-trees, and then they use the T-file service for that. Source modules, so analyzer modules, they're run at the end of the schedule. So when an event is read in from a source and all these producers are called, then the analyzers are called after everything's been produced, because you might want to analyze what you've been producing. Source modules read the data in from the input file, and then they put it into the event data store. Now, the root input source is the one that most people use, and it comes configured in most Fickle files. And it's actually an interesting one. It provides delayed reading of T-tree branches. So if your events are gigantic, and I mentioned that a FAR detector raw data event is 4 gigabytes in size, you may want to read only some of that, or you may want to not read the TPC data at all if you're interested in photon detector data. So what root input will do is it won't actually read in all the data for an event at a time. It'll wait until your module needs it. And when the module goes and calls, say, go get the data, either GetHandle or GetValidHandle are the calls to retrieve data from the ART event. If it's not in the event yet, it'll go to the ART will go to the file at that time and fetch the data out of the file, put it in the event, and give you a handle to it so that you can access it in memory. So that's what the source does, is it simple sources will just copy data from the input file to the event memory, and root input is nice. It's got delayed reader, and we'll do that only on demand. Services are bits of code, they're plugins that do not process events. So these are things that, well, they're singletons, and they're globally visible. So that means that you can access them from inside modules. And the typical thing that you need to know from a service is things like the geometry and things like the drift velocity or maybe the argon temperature. So if your simulation or reconstruction needs information, certainly about the geometry, so you need to know where channel number 1000 is in the detector, you query the geometry service. And these services are shared. They can be called by any module, and they're configured by Fickle so that you can change the job's geometry by just changing that GDML file in the services, appropriate services block. We have a fairly new, this is one that was added a few years ago, called a tool. A tool is a lot like a service, but they're not singletons. So they're swappable you can call them from other modules, but you can also say swap different ones in. So a module may say, I need a tool that will denoise my raw digits. And that's, say we've got different ways to denoise raw digits. We've got a frequency filter, a sticky code remover, and something that fills in gaps, for instance. And maybe we want to apply some of these tools, but not others, and we want to try them out. So what people have done is they've written a tool to do each of these processes and then configure them at Fickle time to say which ones need to be run. In order to make some code, some of these plugin codes, there's a program called CTSkelgen. And I really should go through this help thing for you first, because it turns out that the CTSkelgen help is badly formatted. It says it may be a binary file, and the answer is yes, type a Y there to see the help. So all the other art command line tools have help that just displays to the screen, but CTSkelgen, for some reason, gives you that error message when you look at its help. So what CTSkelgen is, it makes a skeleton bit of source code for you. You give it, say, the module name. You have to tell it whether you're making a producer, an analyzer, a source, a service, and I think it'll do tools. I haven't made a tool with it. I always did that by hand. And then it'll make a boilerplate code for you. So let's say I want a producer module, and then I give it a name. So let's see, CTSkelgen. Oh, I forgot already how I'm supposed to. Oh, I think I just give it 2 arguments. CTSkelgen migrate producer. And I can't put an underscore in that because I'll confuse the build system and the dynamic library loader. Migrate producer. So here is a boilerplate producer module source file. And it's nice that CTSkelgen did all this for me, so I didn't have to type all these includes. And this defines the required methods. So there's a constructor, there's a produce method. So this one produces, and these are, I believe, the constructor and the oh, these guys like equals are disabled. So delete. So you shouldn't be able to use the equal operator on a producer module. So that's the constructor. The constructor should say what data products this thing is supposed to produce, and then what it consumes. Produces are obligatory, consumes are optional. With ART version 3, there are multi-threaded options, and turns out that ART 3, when you throw appropriate switch, will enforce that modules declare what data products they want to consume. And the reason for that is that in the multi-threaded case, you need to schedule modules in an order so that the things that something is consuming are actually produced before they need to be consumed. In a single-threaded case, the list of modules in what order they get called is defined by the Fickle file trigger path, and then you simply need to declare what you're producing. So here's the module that, or the bit of source code that produces. If you actually want to look at an example, should I show you an example? Code is in GitHub, by the way. LARSoft. So let's look at that radiological generator. LARSim. Pretty sure that the event generator, LARSim event generator should be in the radiogen. There it was. And that's the thing that was making argon 39. produces. And here are examples. Here's the constructor, and it's got the calls for produces for MC truth. And there's this run data, I guess, which accumulates things like lifetime and what have you. But the main thing this thing produces is the radiological simulation, which are MC truth data products. And then the produce, is this all the constructor? Yeah, so it reads in the configuration to see which nuclide it needs to simulate and what volume it needs to simulate it in. And then the actual produce method calls other methods like the sample method to actually generate the MC truth for the particular nuclide that was being generated. So that's an example producer module. Okay, where is my? Okay, so that's CTSkelgen, and you can flesh it out once you make the skeleton. Retrieving data products. Oh, let's see. Get by label. Actually, get by label is deprecated. I removed them all. In fact, maybe I'll update this. This is one of the things I forgot to take out of the wiki page, is that GetValidHandle or GetHandle. You'll find a lot of GetHandle calls. In fact, let's go ahead and just do an examples. Let's look for ProtoDune. Oops, no. In DUNE. How about DUNE? And I know that there's a analysis tree maker, analysis tree module. So what this does, it's a very large file. It's 265 kilobytes. And what this does is it reads a lot of data out of the event and puts it into an analysis T-tree. So let's, and they didn't even put consumes in there. It's an analysis module, so there are no produces, GetHandle. So here's an example, that's for the POT summary for the subrun. Let's get an event stuff, hits. So this is a line that gets hit data out of the art event. It gets a handle for that, and then it fills a pointer vector for hit list handle. And then we can loop over that hit list handle. And this finds associations between raw digits and the hits. That's what we were getting, is hit list handle. And then, oh, that's also finding associations. Find many P as an association with their upper. And we find this hit list several times in this module. Ah, there we are. So here we are. Oh, no, we're still finding associations between clusters and hits. But there are loops over hits in here, and they take the hit list handle and loop over the, you should find examples of loops over the hit list handle in there in order to figure out how to retrieve the hits and use them. Okay, let's go back to there. So that's retrieving data products. And you do it with GetHandle and GetValidHandle. GetValidHandle, by the way, will throw an exception if the data product is missing from the input tree. So you find a lot of idioms in DUNE code for, we have GetHandle, and then we check to see if the handle is null. That's a bit more robust than GetValidHandle, which will throw an exception, which you have, well, I guess you can catch the exception. Okay. Much time? I only have a bit left. There's gallery. There are gallery examples. I won't go over those. They're in DUNE examples. I think DUNE examples. Show you where the example gallery scripts are. DUNE examples. And these, by the way, the gallery scripts are not compiled. So I think they may not even be installed. Depends on whether CMake lists. Yeah, okay, we install the source, but we don't actually compile it. So a typical gallery script, for instance, this does FFTs of raw digits. So it'll read in raw digits out of the input file. So this isn't even art. This is a lightweight way of looking at an art root file without actually firing up the art framework. This particular bit of source runs as a root script, so you don't even have to compile it. If you're in a hurry and you just want an FFT right away and don't want to write a module to do it, you can use gallery to do that and find the gallery examples. Okay, so LARSoft. Any questions, by the way? I'm not looking at the live doc or the questions. So LARSoft is a toolkit. It's based on art. So it's got a lot of art plugins in it, and it's got Fickle files, it's got producer modules, it's got analyzer modules. It's got a few input sources, but really the input sources are more experiment specific. The root input source is general enough for everyone to use, but if you're inputting a special DAC format for an experiment, those tend to be in the experiment code. So this is that link to that presentation of Tingjin's from 2019, which describes what all these data products are. So MC truths are the output of the generator. So if you're running radiologicals, and it'll tell you where the 4 vectors are for the radiological electrons, photons, or alpha particles. MC particles are, or beam particles for the beam generator, cosmic rays for Corsica. MC particles is the output of the GEONT step. So you start with generator particles, but once they interact with the liquid argon in the detector or the cryostat or other material, they typically make a lot of other particles. And that whole list is simulated by GEONT and then put into MC particles. So these dumpers, what they do, these are Fickle files, which you can use on an art root file and history. And we had this Monte Carlo file here, so I can run product sizes dumper. Or not product sizes dumper, I want dump MC particles, Fickle, in that root file. So that's a typical invocation of the art executable, is you give it a Fickle file and an input file. And I see I was kind of stupid, so I'm going to Control C out of that. I'm going to say -N1 because I don't want to dump all the events, MC particles. That's a lot. Remember, MC particles was the #1 data product in the product sizes dumper. And the good thing about dump MC particles is that it makes an output file instead of dumping everything to the screen. Well, some of these dumpers, I think, will dump things to the screen. So you can dump sim channels as a simulation truth thing, as a sim energy deposits. That's the output of the GEONT step, as our energy deposits to give spatial positions of energy and what particles produced it. Sim channels, on the other hand, tell you about the which wires were hit. And of course, for photons, raw digits are after the digitization. Wires, I got to tell you about some naming choices that weren't the greatest in LARSoft. And one of them is the use of the word wire. So wire means several things. The APAs have sense wires that wrap around, and a channel is the set of all wire segments for a particular physical wire. So the wire wraps around and then it's connected to readout electronics at one end. But we have to talk about which wire segment once we disambiguate the hit. So those are called wires, but we also call the processed waveforms wires for reasons I do not understand. So raw digits are the simulated or real waveforms that are read off of the ADCs, but these are filtered and scaled and deconvolved to something that represents the charge arrival after denoising and deconvolution and gain application. All these processed waveforms are called wires. So that data product called ReCA-B wire is a reconstructed, filtered, deconvolved version of the raw digits, and that's called wire for reasons I do not understand. Hits are pulses that are found on channels, and they are done with ReCA-B wire as input. Clusters are groups of hits. Tracks are also groups of hits, but they have track parameters in them. PF particles are the output of Pandora, and that's particle flow particles, and they can be either tracks or showers. An event dump pretty much just lists what data products are present in a detector. So you can try these out. In fact, there we are. LAR will give you an event summary like this, tell you how many events were processed and how much memory and time you used. And let's see what we got. So this was thankfully not not sent to my screen because it's 446 megabytes big. In fact, we only have 2 gigabytes in my home directory, and I'm doing this in my home directory, so I'm going to delete this file right away. But let's look at it, and Emacs will complain saying, are you sure you want to open that file? And the answer is yeah. And hopefully you'll be smart enough to only open some of it. So if you want, and I recommend this as new users, whenever you're looking at a Monte Carlo sample, you want the truth and get an idea of where the particles actually went. There might be a dump MC truth. Was there a dump MC truth? Yeah, there's a dump MC truth. And that's from the generator. This is the output of the Jan step, and you get the trajectories, which is why this file is so big. And I'm going to delete that right away. The dump MC truth. That might be a little easier. Okay, so I actually did all of this. Only have 15 minutes left, and this takes a little while to do. So I actually have already done this. Let's look at the MC truths. This might be easier to look at. Remember them. So these are singles gen. This particular file was generated with, I guess, that single particle generator. And do we have radiological sense from radio? Nope. This seems like it was made with singles gen. Okay. And what is it? And this positron, electron, muon. Maybe this is the cosmic rays. These look like cosmic rays. And let's see if I do have the tutorial tests. And do I have, that's the old one. I thought I did a new one for this year. So I ran through this as a, no, but we can look at last year's because it's actually the same tutorial. So that's how you invoke an art job, is just with the LAR executable. By the way, there's also the art executable, which art, and art is the same thing as LAR, in fact. And the reason for this is because the art team made a special art executable for the LARSoft experiments and called it LAR. And the reason for that is to allow the LARSoft experiments to customize it. So if there's anything that we wanted to change in the art executable that couldn't be done just with plugins, we had the option to do that. We never used that option. So if you use art or LAR, you'll get the same answer because it's the same simple program whose whole job it is to simply load up the things that are in the configuration file. So I ran through this exercise a a few weeks ago, but I must have deleted the output because I left. Let's see if I still have that. In data 2, I put in data 2. No, I don't see it there. Okay. I did some of this exercise. Let's see. Config output. Do I have that? Config output. So the way we have our workflow set up for ProtoDune and the FAR detector is that these jobs are divided into several pieces. One does the generation. So this does Beam and Cosmic's generation, and it makes those MC truths. It doesn't even run Géant, so you don't have any MC particles beyond the ones that MC truth needs. Then there's a Géant step, and in fact, that's done in 2 steps because there was a memory and CPU issue with running the Géant 4 in just one job. So in fact, these workflows are separated into several stages because of memory and CPU needs. So the Géant 4 stage is done in on 2 of these stages, and then there's a DETSIM stage. What DETSIM does is it takes the energy deposits that are made by the Géant 4 step and then drifts them, computes the drift time and simulates diffusion and the channel response given the field response and the electronics response of the wires, and outputs raw digits. Then we reconstruct raw digits, make Rickaby wires, Rickaby hits, Rickaby clusters that are analyzable. And then what this event dump output, did I make an event dump output? So that was one of the dumpers that I didn't show. And this is like product sizes dumper. It just gives a list of the data products and the module labels. In fact, I've got this a little bit too big. There. So as I mentioned before, a lot of the instances are empty. Module label, this is generator. So that was the beam generator. This is krypton, argon, radon, radiological generators. And then there's Corsica for cosmic rays. And they all make MC truths. And then Géant step should make MC particles. MC particles. Those are associations. Oh, may not save MC particles. We might not have saved all the MC particles. Or maybe I just didn't spell it right. Oh, you kept, there it is, large Géant. That's the Géant 4 step, made MC particles. And then the detector simulation step does all the, oh, okay, so that's the Géant 4 step, ran large Géant and made MC particles. And that sim is making raw digits and also the optical detector. And Rico makes the wires hits. I think we dropped the wires in the standard workflow, but you can turn them back on. In fact, do we have the output switches? I'm always forgetting what the key. Nope. I think it's later on in the tutorial. We talk about output commands where we keep and drop some data products and keep others. Okay, one other thing I should tell you guys about is to make sure to have an inspection copy. Actually, I make a symbolic link. I have a directory in my home directory, or a symbolic link in my home directory, because the symbolic links are small, to a place on DUNE app where I've checked out a bunch of source code. And here's a little script that shows you how to check out an inspection copy. So if you don't know where to find stuff and you are looking for an example, and this is often what I have to do, is I go through Slack every now and then and people ask, how do I do XYZ? And then I dig through the LARSoft code and the DUNE code in order to find an example, because I know that examples exist for a lot of things that people want to do, but then I have to look for it. So what MRB does, this is MRB Git checkout, will check out a whole bunch of Git repository code. So the entire LARSoft suite actually got refactored into two pieces, LARSoft and LARSoft Obj. So these checked out all the source code, put them into my DUNE app users directory under inspect. And then what I will often do is just grep-r. You'll notice that this is frowned upon for Dcache, but for your own source code in DUNE app, this is often what I do. So if I do grep-r, get handle start. What that will do is it will look through all the repositories for instances of GetHandle. It won't be the quickest, but if I have no idea where something is, then I can find examples in the inspection copy. The build, we'll talk about building these things tomorrow in the modify module session. I do not recommend building the entire LARSoft and DUNE suite. There are things in the continuous integration system that will do that. Oh, there we are. That's my example for finding find many P. So if you want an example of finding associations, you can grep-r. And often I forget the capitalization too, and grepping with -i ignores capital and uppercase and lowercase. And here I've limited the grep. Yeah.
Do you want to show maybe a slight digression into looking on GitHub for this? That might be a bit easier as well.
Yeah, sure. Now, I'm actually not very good at grepping through large amounts of code in GitHub, so maybe you can tell people how to do that.
Okay. Do you want me to sort of direct you, or I can share my screen?
Yeah, why don't you share your screen?
Okay.
Unsure if you could do that.
It says host disabled participant screen sharing. I might need to be promoted to co-host.
Yeah, let me try. Jake.
I trust everyone, so I just enable green screen share. This is my little experiment to answer the question of whether a session will get kicked out or not if I run top. It's been running for about an hour and a half.
Let's see. How's that? See if that works.
Okay. Yeah, it should be good. Okay. So I'm on, let me get rid of my Zoom windows. Okay. So I'm on GitHub right now. And we have the DUNE organization. So this is basically, it's like a user sort of, it's similar to a user, and it can contain multiple repositories. And we do have multiple repositories like Tom was showing. DUNE SW doesn't really have code in it. It just sort of houses, it's like, it's sort of the top of the tree, and it sort of links everything together, and it houses Fickle. So I won't go in there, but I'll do ProtoDune Anna just because that's the one I'm most familiar with. And for example, we can look for find many P, and there's different options that pop up. You could look through all of GitHub, but you probably wouldn't want to do that. You can look through all of the organization, so that will look for this string of characters throughout the various repositories, like I just mentioned. Or you can also limit it to this repository as well. So we'll click on that, and you can see it here. It'll find whether it's the includes for the headers or the actual sort of instances within the code itself. And we could just probably look at that, and then maybe do a Command F to search through here. That way. Now, so that's the way that I've preferred to do it. Since moving to GitHub, it's been quite easy to do this. One issue is that sometimes sometimes I found that if you don't get it particularly correct or exactly correct, for example, if I leave out find many p and just say find many, it doesn't find it. So that's one slight issue, is that it has to be like a whole continuous word, and it will, I guess, separated by maybe special characters, and it will find it, but it has to be exact. So that's one caveat to this, is that maybe it's a little quicker, but it's only quicker if you know exactly what you're looking for. Okay.
That's handy. In fact, back in the old days, we used to have LXR or Doxygen, but this sounds like it's even more convenient.
Yeah, it's quite nice. Okay, I'll stop sharing. I'll give it back to you.
Okay, well, I'm actually just about done here. I think that was close to the end of my presentation.
Yeah, we're at the top of the hour.
I had a little line mentioning LARSoft, but to be honest, LARSoft's based on art and new tools, just like LARSoft. So you use it in the same way. And it's in GitHub too. Okay.
Right. Tom, you're always so good at that. Thanks.